My name is Dr. Yap Banha, and I will share this problem with you. Two friends, Spiky and Curly, they share 3/4 of a cake. This is the whole cake, but 1/4 has been eaten, so 3/4 left over. Two of them, they are going to share 3/4 of a cake equally. Our problem today is to think of ways how they can do that and to find out how much of the cake does each of them get. Use whatever concrete materials you need. In particular, you have pieces of paper, square pieces of paper to represent the whole cake, and the usual stationery like pencils, ruler, and a pair of scissors. Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. This is the whole cake, and those are 3/4 of the whole cake. How can 3/4 of a cake be shared equally between two friends? That's not too difficult, isn't it? We have made 3/4 into 6 equal parts. Do we know the name of this part? How many of this make the whole cake? That's right, 8 of this make the whole cake. So the name of this is 1/8. Some of us prefer to continue the line to make it clearer that this is indeed an 1/8. So 3/4 is equal to 6/8. Method 1 is to rewrite 3/4 as 6/8. Why? Is sharing 3 convenient to do? How about sharing 6 between 2? 3 divided by 2 compared to 6 divided by 2, which is more convenient for you to do. For me, dividing 6 by 2 is much easier. So, method 1 is to use equivalent fraction. Sharing 3/4 of a cake equally between two friends is the same as to share 6/8 of a cake equally between two friends, and that result in sharing the 6 slices between two friends, and that result in 3 slices for each friend. The name of the slice is 1/8, so each person gets 3/8. Method 2. This is the whole cake, and Spiky and Curly share 3/4 of the whole cake. Spiky takes 1/4, Curly takes 1/4. Remember, they must share the cake equally. What can we do next about the last slice of cake? That is right. We can cut that slice up into 2 equal parts and let Spiky take one and Curly takes the other. What does Spiky get? And what does Curly get? Spiky gets 1/4 and one smaller slice. Likewise, Curly gets that amount. The question is, what is the name of that triangular slice? How many of this make the whole cake? That's right, 8 of this make the whole cake. So the name of that is an eighth. So Spiky gets 1/4 and 1/8. Curly gets 1/4 and 1/8. Method 2 needs us to do a little bit of adding. So sharing 3/4 equally between 2 friends, we can see that 3/4 is 2/4 and 1/4. Sharing 2/4 between 2, that's easy. That means each person gets 1/4. But sharing 1/4 between 2, maybe we can cut it up into 2/8, because now sharing 2/8 is much easier to see. That means Spiky gets 1/4 and 1/8. And by continuing with the addition, we can figure out that Spiky gets a total of 3/8 of the cake, and Curly also gets 3/8 of the cake. Method 3. Sharing 3/4 of a cake equally between 2 friends simply means each of them gets 1/2 of it. Sharing 3/4 of a cake equally between 2 friends result in each of them getting half of whatever they are sharing. But what if 3/4 of a cake is shared equally among 4 friends, or among 5 friends, or among any number of friends? Can you see how much of a cake each person gets? What if they share among 4 friends? That is right, each person gets 1/4 of whatever they are sharing, and they are sharing that amount of cake. So each person gets 1/4 of 3/4. And if there are 5 persons or 7 persons, are you able to see what fraction of 3/4 of a cake they are going to get? When they share among 5 persons, each person gets 1/5 of whatever they are sharing. And if there are 7 persons, that means each person gets 1/7 of whatever they are sharing. And for this problem, that is 3/4 of a cake. Today is a clever day. There are 3 ways that we have found to solve today's problem, which is 2 friends, Spiky and Curly, sharing 3/4 of a cake. In the first method, we use equivalent fraction. In the second method, we use addition to complete the problem. And in method 3, we see that we can use multiplication to help us figure out the answer. I hope you're able to understand at least one of the 3 methods. You have learned today's lesson well if you can do that. Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Paulia, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities and exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation. That is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Scamm's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in Method 1. For average learners, they should be able to come up with Method 1 and Method 2. And if they're advanced learners in the class, Method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.